All right, folks, welcome to Module 3 when we start to get into our actual statistical calculations. This module focuses on what's known as central tendency, which is basically a simple attempt to summarize all of the scores in an entire data set, sometimes a very large one, with just a number or two. So, purpose of central tendency, first, to see where we're going, let's talk a bit about where we've gone. In the previous module, we talked a bit about the most basic thing we can do with data, which is to organize it, to put it in a form where it's easier to make sense of. So we learned how to make various frequency distributions, graphs, tables. We learned to identify the shapes of different distributions as well. Here, the next sort of more sophisticated thing that we can do with our data is try to identify sort of simple patterns or tendencies there. Try to come up with figures that represent overall patterns in the data set, and to keep that information, those figures, those numbers, as simple as possible. So these basic sort of summarization statistics are known again as descriptive statistics. They describe the characteristics of our data set. They try to provide as much information as possible in as little information as possible. So again, frequency distributions and graphs, they help us get a sense of the overall shape of the distribution, but they don't give us a heck of a lot of other information. So one of the most basic descriptive statistics that we can use is a family of descriptive statistics known as measures of central tendency. Now, you've probably heard about these before in high school math. Some of it's pretty basic, but again, we're going to take it quite a bit deeper, especially with regards to how we're going to use it to understand our populations. But the purpose of central tendency is this. We want to get one single score that's the most typical or representative of the entire group of scores, usually trying to find a score that's somewhere close to the center of that data set, something close to the middle, and there are different ways of defining how we get to that middle. But we want one number that boils down the entire data set and sort of pinpoints the middle of that distribution. So we'll talk quite a bit about the actual calculations of central tendency, specifically the mean, in our next lecture. But for now, this section of the course is the first time we're going to be discussing formulas. If you've been reading the book, and you should have been, you're going to have seen some of this stuff before, but I want to talk about it a little bit because, again, it's important that you hear it explained from me instead of just from the textbook. So I mentioned back in the very first module that part of the difficulty of this course is that it's like speaking in a different language. Formulas, again, have a lot of the words and phrases that come in that language. They involve essentially symbolic representations of different quantities and different functions that we can do, different operations we can do with those quantities. These things are summed up by symbols. Here's the thing about these symbols. They can be a little intimidating. There's not that many of them. There's really just perhaps 6 to 8 of them that we're going to see really, really frequently, and then a handful of others that we'll see less often. Become fluent in those symbols in that language as soon as possible. Even if you understand the concepts just fine, if you can't interpret the formulas, you're not going to be able to do the calculations correctly. Even if you can kind of get through the formulas, but you don't really know what's happening at each stage and why, that's going to hurt you in the conceptual areas. So be familiar with these symbols and how to apply them and how to work these formulas. You will always have formulas provided for you during exams. You'll have the sheet in front of you. You do not need to memorize them, but you're going to need to know how to work them and what to do with them and which ones to use. So these formulas involve symbols. They're simple. They repeat over and over again. The quicker you get them down, the better off you'll be. Many of these symbols are in Greek, you'll notice. Some of these formulas look kind of like the facades of like fraternity houses or whatever. The reason why is that Greek is associated with ancient math, so early statisticians used to use Greek as kind of a common language. So we continue that tradition today. So we're going to work on how to calculate this formula in the next section, but first, here's our first formula of the course so that we can talk about what these symbols mean. This is a formula for the mean of a distribution, which is sometimes better known as an average, and we have an m equals, this is the Greek letter sigma of x divided by n. So let's break down what those things mean. M refers to the mean. It's what we're trying to calculate. More specifically, it's a sample mean, but we'll talk a bit more about that later. Some other people may call it the x bar and x with a line over it. You might see that once or twice in some of the materials here that weren't easy to change. but those are interchangeable symbols, but generally we're just going to be representing it as that capital M. That sigma, again, is a capital sigma, and what it means is sum up whatever's in front of this symbol. So sum up whatever happens after this, add them all up together. X is a generic stand-in that you should know from algebra. It's a generic stand-in for essentially any number. So in this case, it means all of our scores. So sigma x just means add up all the scores you've got. Then divide it by n. N is another really common one. It's the number of scores in the distribution. You got 10 scores in your distribution or your data set, divide by 10. If you have 100, divide by 100. So all this is saying is the mean is calculated by adding up all the scores, dividing by the number of scores. Pretty basic stuff, but we're going to see each of those symbols quite a lot and in some more complex contexts. So make sure that you're able to recognize them when they come up and that you are able to do the calculations that the formulas call for. And again, the sum of x, sigma x, just means add up all the x's, add up all the scores on the variable we call x. That's all the time we have for now. So next up, we're going to start using that formula and talking a bit about calculating and applying the first measure of central tendency to the mean. See you then.